Woohoo! We're live. This is Math 60, Intermediate Algebra 6.3, pages 1 and 2. And this is well known as everyone's least favorite section until we get to the word problems that involve fractions. But before that, let's go ahead and talk about addition and subtraction, which up until now were probably your good friends, and we're going to learn to hate them. So, shall we get going? Woohoo! Yay! Hating fractions! Yay! Okay, it's actually not that bad, especially if, when you're asked to do something with fractions, if the denominators, or the pants, as we're going to call them later, of the fraction, if they match, if I have 3/4 plus 2/4, that's equal to 3 plus 2/4. In other words, 5/4. This is very much like saying 3 puppies plus 2 puppies, except I can't spell, equals 5 puppies. Like terms, like terms. So the denominator tells you whether or not these creatures are like terms. These have common denominators. But oh no, what if they have two different denominators? If they have two different denominators, it's like saying I have 1/2 plus 1/3 is like saying I have one cat and I have one puppy, and I add them together. How many puppies do I have? And the answer is, well, that's a weird question, isn't it? So what we're going to do is we're going to say, in order to add them, we have to come up with common denominators. These are unlike or different or uncommon denominators, which I don't think anyone actually says. So there are a couple of phrases. The least common multiple, which is another way to say the smallest number they all go into. This part right here is the common part. So least common multiple is the smallest number they all go into. So if we're looking at the numbers 2 and 3, right, what numbers do they go into? Well, they both go into the number 6. They both go into, let's see, the number 12. They both go into the number 18, and so on. This is least. These are all common multiples. Okay, so that's what least common multiple means. Let's turn off my sound. Elsewise, you get to hear all the binging and banging of everyone sending me email. Okay, so there's another shortcut, or what do you call it, acronym. LCD is the least common denominator. I generally use these two interchangeably because a denominator can also be a multiple. So as long as you're talking about fractions, you really can get away with LCD or LCM, up to you. But basically, if I've got 1/2 and I've got 1/3, the least common denominator, we're looking for 6s. So here's how I'm going to do it. Now, hopefully, I'm hoping, fingers crossed. Look at that, I did it without even using my other hand. Fingers crossed, I'm hoping that you already know how to do this. But just in case you're a little rusty, let me show you. I say, okay, 1/2 is how many sixths? And then we think, well, 2 times 3 gives me 6. And so I'm going to go ahead and multiply by 3 on top. Here's the thing. Fractions are a lot like equations. Fractions, though, balance top to bottom. You know how equations, you have to do the same thing on the left and the right? I think I got that right. In a fraction, you have to do the same thing top to bottom. That's their balance, is top to bottom. So 1/2 is really 3/6. 1/3, let's convert it to sixths. 3 times something equals 6. 3 times 2. If I multiply on the bottom by 2, I have to multiply on the top by 2, and I get 2/6. So my new addition problem, my new sum, is going to be 3/6 plus 2/6, which now have common denominators. Yay! And I get 3 plus 2 on top, which is 5/6. Woohoo! Now, could you have done this with one of these other numbers? Could you have done it with 12ths or 18ths? Absolutely. Any common multiple will work. But if you can find the smallest one that is common for them, then this will not have to be reduced. If we had used 12ths or 18ths, we would then have to do one more step to reduce it. So it just depends on how much time you want to spend reducing your fractions. That's why we go for the least common denominator. Now, this is not always as simple as this problem would suggest, which is why I have a whole new, brand new set of puppets. I know you guys are very excited. I'm very excited. Everyone's very excited. I can tell the cats and the birds outside are very excited. We're going to talk about finding least common denominators with a concept called pants math. And the important movie here is an old movie now from the 90s. It's called The Sisterhood of the Traveling Pants. And it was also a book. Very beloved. You may have read it. It is a beloved. Here's my puppet for The Sisterhood of the Traveling Pants. So here is basically what happened. So basically what happened in this book, in this movie, and I find this charming and amazing and a little bit strange because personally I find pants to be kind of funny for whatever reason. I think they are kind of hilarious, actually. You could just walk up to me and say pants and I'll just burst into laughter. So there's a magical pair of pants, which already I'm sold right there. A magical pair of pants that anytime someone puts them on, no matter who they are, they magically fit, which as a person who is on the small side and also, well, generally doesn't wear a lot of pants, but whenever I've tried to buy pants, they're way too long for me because I'm kind of on the short side. So a pair of magically always fitting pants seems awesome. And so it got me thinking, put this over here, Sisterhood of the Traveling Pants, which is, I've heard a great movie. I've never seen it. Oh, and what's important is when you put on the magical pants, then you go on magical adventures, which I find even more awesome. And I have checked with people who have read the book and watched the movie. They confirm that although I'm missing probably some key points, that basically I am not lying about what this movie is about, even though I've never seen it nor read the book. So it dawned on me that all these fractions, the denominator, look like pants to me. They're fraction pants. Okay. So I know these are going to be some of the weirdest notes. Anyone who doesn't watch the video is going to be so confused. So this is the most puppets I've ever made at one time. Ding. So I want you to imagine 2 spiders. Now, one spider, as you can tell, looks more like, it actually looks like a tick or a lice or something. It's a very tall spider. And this spider is a very short spider. And so I've designed pants for each of them. So here's this one's pants. I know it doesn't make any sense. I know this brings up the question of how would spiders wear pants, but let's just go with on their bottom halfness. So this one wears these pants, right? And this tall guy, I don't know how to get this in here, but basically these are the tall guy's pants. I'm going to have to turn him a little bit sideways. Okay. So they have pants that fit them, right? They would not be able to wear each other's pants. Like these pants would not go around the shorter guy. And these pants, they wouldn't go up high enough. This would be kind of embarrassing. These are not long enough for the tall one. So here's the thing. We want to find a pair of pants that fits both of them. Are you ready for this? Now, the problem is if I get a pair of pants that fits both of them, for the really tall one, they're going to be tall enough, but they're maybe a little too wide. You can see he's gonna need a belt for these. They're too wide for him. And for the shorter guy, they're nice and wide for him, but they're gonna have to roll up the bottoms. But you know what? That's okay. Because if this spider were trying to get into these pants, turn you sideways a little bit. I gotta put the sticks on the other side. That's never going to happen, right? So the pair of pants that this one would wear, never going to fit. So what have I done to find this pair of pants? Well, what I've done was I've looked into what each one wanted, and this spider needs them to be this long. So we went to the taller spider to figure out how long they should be. Even though they're a little long for the short one, that's okay. And this spider, a little wider around the middle. So we made pants that were a little wider around the middle. And that means that this spider will have to wear a belt, but that's okay, right? You can put on a belt, you can roll up the ends. Now, here's the question. In the movie, do they all have to wear the pants at the same time? No, of course not. This was like a G-rated or PG-rated movie. Each person wore the pants separately. We didn't try to put a bunch of people into one pair of pants. Same thing with the spider. One spider wears the pants at a time. They go on a magical adventure, and then they come home and they trade off the pants, and then they get to go on a magical adventure, right? So that's my suggestion for a movie. Don't nobody steal that. I'm gonna make it big in Hollywood with my magical pants spider movie. So, what the heck does all of that ranting mean for this nasty collection of fractions? Well, what we do is we look at the denominators. So I'm going to list the denominators. And then something that you're going to see me do a lot is I'm going to break the denominators down. I'm going to actually say, okay, what is actually going on? So this denominator, this pair of pants, is 3 times 2. 4x, this pair of pants is 2 times 2 times x. Do you see what I'm doing? I'm breaking it down into its prime factors to the smallest pieces. Now 12 is a little exciting. It's 3 times 2 times 2 because it's 3 times 4. And then there are a couple x's there. And then this one is very conveniently always, pardon me, already broken down. So now what are we going to do from here? Well, from here, we're going to remember the most. Now, what does the most mean? Well, with this spider was the most tall, so I made really tall pants so they'll fit this spider. This spider was the most wide, and so I made them big enough to fit the most wide. So for each of these, you want to look through and you want to see, okay, where's the most 3s? I've got 1 3, 0 3s, 1 3, 0 3s. So the most for my LCD, I need one of the 3s. Okay. Now let's look at the 2s. 1 2, 2 2s, 2 2s, 1 2. What's the most number of 2s? Not all of them, not 1 2 3 4 5 6. Don't count them all. Because remember, you don't have to wear the pants at the same time. You want to just take the tallest person, or the person with the longest knees, or whatever it is, the person with the widest ankles, because you got to get the pants over your ankles, that sort of thing. So I'm going to look for the most number of 2s. What is the most number of 2s? You got it. 2 2s is the most number of 2s. So I'm going to go with that. Now, how about the x's? There's 0 x's, there's an x, 2 x's, 1 x. The most is 2 x's. And then do I have to include a y? Because it's just like, there are no y's here. And the answer is, well, if you don't put this y in there, then this one's not going to fit those pants. So I got to put in the y. So it's 3 times 2 times 2. So that's 4 times 3. That's 12. X squared y is our least common denominator. Or we could also call it the least common multiple if you wanted to. What is the other way to find a common denominator? Well, one way to find a common denominator, if you really don't have time, is you take these, you multiply these all together. This is going to be really massive, like massively gigantic, right? Because this is 6 times 4 is 24. Times 12 is like 288. Times 2 is like, I don't know, 576 or something like that. 12 is a much nicer number to look at. Does 6 go into 12? Yes. Does 4 go into 12? Yes. Does 12 go into 12? Yes. Does 2 go into 12? Hot diggity dog. Does x go into x squared y? Yes. X squared? Yep. XY? Yep. We have managed to come up with something that's way smaller than whatever number I said, 576 times x to the 4th y. This is going to be much easier to look at, and we will have less to clean up at the end. Okay, so there we go. That's the LCD or the LCM for these. Woohoo! Are you guys ready to do some addition and subtraction? Yay! I know most people don't really love it, but let's do that. Next video, let's start adding and subtracting. You got it. I know. We're so cool. We are the coolest ones there are. Nobody is cooler than us.